stoichiometry next week in lab. A zinc and iodine reaction, there's going to be a limiting and there's going to be excess. So what we are doing now today is everything we're doing for lab. Now, I urge you to work on this as soon as you can when class is done. Get a partner to work with. I met with 2 people every day after class last semester. They worked on it right away, and pretty soon it turned into 3, 4, whatever. So work on something as soon as you can after we get done. Try to work on it, especially the quiz problems. Look at the owl. Okay, up there on the board, again, I shouldn't have put 11 on there yet. We got number 2. Let's look at number 2. How many? So this is just a nice review then of where we're at. So how many grams of CO2 gas are produced? And how many grams right here from 10 grams of isooctane? Well, the only thing that looks like isooctane, or that you don't know, hopefully, water, carbon dioxide, oxygen, 10.0 grams here. What is the very first thing we are going to do? Turn this pig into moles, right? We can't do anything in grams. We can't do any mole ratio steps in grams. So the very first thing we are going to do is we're going to take this 10 grams and we're going to turn this into moles. And I'm going to do it right down here. We got 10 grams of C8H18. Let's see how you're doing memorizing these. Carbon is 12.01, hydrogen 1.01. So this is grams. 1 mole. Now, please write all of this down. I've looked at exams before and the scores are not good. And I look at it, there isn't 1 unit written down. Not 1. Please write down the units. You know that this is going to cancel out then. So we're going to have 12.01 times 8 is 96.08 plus 18.18, 96.08. So 96.08 plus 18.18. I think we get 114.26. Anybody 114.26? Thank you. We got the vertical non. 114.26. Now, how many moles? 1 mole, right? So there's nothing different. 1 mole. So when I divide this out, I'm going to have 10. And I get 0.0875 moles. The 3 sig figs. 10 grams is 3 sig figs. I've got 5 sig figs, so I'm keeping 3 sig figs here from what I started out with. How many moles of CO2 is it going to produce? Now, we have to have oxygen, obviously, so we should say we have excess oxygen. So here is my mole ratio step. As soon as I point my arrow this way, my mole ratio factor fraction should be 16/2, right? As soon as I point my arrow here, that number that I'm trying to figure out goes on top. The number that I start, or the arrow where I start my arrow, that balanced equation number goes on the bottom. 16/2, and 16/2 is just 8. So I'm going to multiply this times 8, and I get 0.700 moles that I'm going to produce. Now, I don't want that in moles. I want it in grams. So I can do this right here. I've got just enough room. 1 mole of CO2 is going to be 44.01 grams. That's going to do it. Now, let's review what we did. We started out with grams, but we can't do anything in grams. We immediately switch it to moles. So this is just the molar mass, 1 mole. That's our starting moles. We draw our mole factor fraction arrow. It's 16/2 from the balanced equation. We're taking this moles right here and we're switching this back to grams. Okay, please don't overthink it. 1 mole here. Just look at it. 1 mole, 1 mole. Okay, so now we're going to look at 5. So 5, all right, 5 is an interesting one because it involves 2 reactions. And I expected 5 to be on here on the board. And there's another one we'll probably have on the board next time. But here's what we've got. It says nitrogen right here. Whoa. Nitrogen reacts with magnesium to form magnesium nitride. Oxidation, reduction, synthesis reaction. Let's just review that. No charge, right? No charges here. +2 -3. Oxidation, reduction. Okay. Then this product reacts with water to form magnesium hydroxide and ammonia. So this product right here, my product from this reaction, is then reacted here. Now, here's what it says. How many grams of magnesium would you have to start with to prepare 15 grams of ammonia? We're looking for grams of magnesium up here. 15 grams of ammonia here. So here's what you're going to do. We're going to take 15 grams, turn it into moles. We have to. 15 grams to moles. Then we're going to calculate moles that we reacted here to form the 15 grams. Where did those moles come from? It came from this reaction product. So this will be the same number of moles. Then we got to go to here to figure out moles of magnesium that we started with, and then we're going to go to grams. So what is my mole factor fraction going this way as I draw my arrow? This right here is going to be 1/2, right? 1/2. Then whatever you get for moles here is going to be exactly the same. But then when I go this way, it is going to be 3/1. That look right? Okay, so you can convert grams to moles, moles to moles. The moles that you start out with for this reaction were produced here, and then moles to moles again, and then moles to grams. Okay, the next one is 9. in 9. How many moles of, okay, PF3 reacts with xenon tetrafluoride, XeF4, to give PF3, phosphorus pentafluoride. 100 grams. So we've got 100 grams here. And we've got 50 grams here. We just want to know how many moles here. Typically it's grams. Wants to know how many moles. So this for sure is a limiting problem. We need to figure out which one runs out first. So we are going to convert this 100 grams here to moles, right? This will be how much we have. Then we're going to calculate how much we need. And my mole factor fraction right here to figure this out is going to be 1/2. And then you're going to figure out how much you have. Where's that going to come from? Obviously, the grams. And then to get your moles here, you come off of what you have of the limiting once you figure that out. So I'm going to leave that like this. If it goes on the board next time we meet, I'm fine with that. But see if you can get this, because we're going to do a limiting problem right now that's going to go through everything again. Okay, so let's do that. So in our learning guide, this is where we left off. We did this example of limiting. And again, this is the lab coming up next week, where we said we had 8 males. We needed 12 females to use up the 8 males. If that was the case, everybody would have been in a group. But we didn't have 12 females, we had 18. So we had excess females. To figure out how many moles of product you get, you always come off of what you have of the limiting, which is either going to be this box or this box. If the limiting was here, if fluorine was limiting, or excuse me, females were limiting, we'd come off of this box. Right? Now, we're going to put this all together. Then we did an example problem here, but let's do this one. This really lays it all out. So, letter A, how many moles of aluminum bromide? So here's what we're reacting. 53.34 grams of aluminum bromide reacts with 19 grams of fluorine. Single replacement reaction. Fluorine takes the place of bromine. So this is single replacement, oxidation reduction. So we're going to react aluminum bromide plus fluorine. We're going to end up calculating how many grams of each product we get. Okay, here's our first step. We know we have to do this. We got to figure out how many moles of aluminum bromide we have. We got to figure out how many moles of fluorine we need. And then we're going to figure out, well, how many we actually have. So let's start right here. How many moles of aluminum bromide do you have? Well, we've got 53.34 grams. So we'll do it right here. And I've got the numbers we're going to use right here. 79.9 for the bromine. Oops, I'm missing an L. 26.98 for aluminum. So grab your calculators. 3 bromines in aluminum, 3 bromides or 3 bromines in aluminum. So 1 aluminum and then 3 bromide gets us 266.68. 266.68. Okay, 266.68. Now 4 sig figs here, 5 sig figs here. I'm going to do this to 4 sig figs in. This is going to be 0.2000 mole of aluminum bromide. So let's go fill this in up here. 0.200. That's what we have, right? For sure, that's what we have. We figured it right out from the grams. So letter B, how many moles of fluorine are needed to use up all the aluminum bromide that you have? My mole factor fraction step right here is going to be 3/2. Yes, 3/2. So if I take 0.2 times 3, I'm going to get 0.6, and 0.6 divided by 2 is going to be 0.3. This is how much we need. Now, let me stop here and say this. 53.34 grams is 0.2 moles of aluminum bromide. I need 0.3 moles. If this 19 grams comes out to be 0.3 moles, I have exactly what I need. There is nothing left over for reactants. Everything is converted to products. Right? Well, let's see. The next logical question should be in your head. Well, if that's how much I need, how much do I have? Right? So that's what we're going to do right down here in letter C. How many moles of fluorine do you have? Well, we have 19 grams. And it's F2 and fluorine is 19. So this is 38.00 grams of F2. One mole. Grams cancel out. So this is perfectly a half. I have 0.5000 mole F2. So I'm going to go up above and put that in that box, right? Because I calculated from the grams. I have 0.50 .000. That's what I have. We're starting to make refrigerator art. So when you go home for spring break, you just put this sheet on your refrigerator. We're making refrigerator art. Do you have enough fluorine? You have more than what you need, right? Therefore, write the word excess here. Write the word limiting here. You have more than what you need. So even though this 19 grams is way less, some of this 19 grams is going to be left over. All of this 53.34 grams is going to get used up in the reaction. The reaction is going to stop when this 53.34 grams of the limiting is used up. Right? It's no different than males and females. If I said we put, what was it, 3 males, 2 females, or the other way around in this corner, and males and females in that corner, and males and females in that corner, I quit making groups and I ran out of males. This reaction is going to stop when you run out of aluminum bromide. Okay, so let's go on. Which one is limiting? Well, ARBR3, which one's an excess? Fluorine. How many moles of the reactant in excess are left over? Well, out of this 0.5 that you have, you're going to use up 0.3. So I guess I could just do it this way. 0.2000 excess. So 0.2000 mole F2. Well, how many grams of the reactant excess are left over? When we just take this right here, we're going to convert it to grams. So 0.2 times 38. 0.2 times 38 should be 7.600. Okay. Now, our refrigerator art is getting better. Bob Ross got nothing on this page. If you know who Bob Ross is, I hope you do. Now, next question. How many moles of each product, aluminum fluoride and bromide, are produced? I'm looking for these moles right here. To find those moles, you come off of what you have of the limiting, right? Because once the moles of limiting is used up, the reaction stops. So I'm just going to come off of this limiting box. It's either going to be this one or this one. I'm just gonna draw my arrow way down here. Who cares? When I point my arrow right here to figure out moles, what's my mole factor fraction going to be for this one? 2/2, right? 2/2. So 2/2 here, I'm going to produce 0.2000 moles of aluminum fluoride. And my moles here, my mole factor fraction would be 3/2, right? Here's my 3. I started my arrow right here, 2. So this is 0.3. So I'm just going to write this down here. How many grams of bromine gas are produced? Well, there's our moles. We're just going to convert moles to grams. 0.3 moles of Br2. One mole of Br2. Oh, I didn't put that in red. 79.9 times 2 is 159.8. So 0.3 to 4 sig figs is 47.94 grams. How many grams of aluminum fluoride produced? One mole. $26.98 and 19. $83.98. 83.98. Okay. So we get 16.80 grams. Now hold on, our refrigerator art's going to get better. We're not turning the page yet. Now look at this. Look at what we've done. All we've done is convert grams to moles, and it's 1 mole, right? Grams to moles, 1 mole. Moles to grams, 1 mole. Moles to grams, 1 mole. Moles to grams, 1 mole. then we're like elementary art students. We're just drawing arrows and boxes and ovals. And when we draw our arrows, once we point our arrows, that number that we're pointing it to goes on top. Where we start, our arrow goes on the bottom for the mole ratio factor fraction. But watch this. Watch this now. Everything has to work out according to the law of conservation of matter. All of the grams that reacted have to go into grams of product. So let's double check that. First of all, you're going to draw a nice arrow like this. I hope mine's going to be beautiful. Oh, that's not bad. I'm going to point my arrow like this. Oh, that's not bad. That's a pretty good arrow. This, when I add these up, is my total grams of product produced. Yes? Total grams of product. My total grams of product is going to be then 64.74 grams. That has to equal, and does it equal the grams of reactants that reacted? The grams of reacted that reacted. So let's go over to the left side here and figure out to see if this works out. First of all, my limiting was ALBR3, and that was 53.34 grams. All of that 53.34 grams went into these two products. Right? That makes sense, correct? So now let's do this for the excess. For my F2 excess, I started with, I'm going to do a left parenthesis here, 19.00 grams. Minus, how many grams did I have left over? My leftover excess, I'll actually draw it from down there. I guess it might look a little ugly, but I'll, right? My leftover, we calculated right here. I'll have to cut it off. Oops, I guess I already drew it there. 19 grams I started with. 7.6 grams left over. How many grams reacted? $11.40 grams reacted. 53.34 plus 11.40 is 64.74. Absolutely perfectly spot on. If you're looking at some problems in OWL or the quiz or whatever, make sure the multiple choice numbers make sense. If you're starting out with these two added up for grams, which is going to be 72.34 grams, you're not going to get more than 72.34 grams of either of these. There's just no way. So double check what you're looking at. This is our completed page of refrigerator art. Everything works out, right? Okay, let's go to the next page. Here's one that I'm going to let you work out. We're going to get you started. It's going to be the exact same thing. We're going to calculate, you're going to calculate how much you have here. This is just burning butane from a cigarette lighter. You're going to calculate how much you need. You're going to calculate how much you have, and you're actually going to go back this way and calculate need here as well. I hope the oxygen is limiting, so we're not doing the same one all the time. Then eventually you're going to figure out your moles over here. Okay, I'm gonna let you work on this one. It should work out exactly like the previous one. One of these is going to be limiting. You're calculating moles of both products and moles back to grams. Maybe I'll have a volunteer give me this next time we meet. We'll just throw it on the screen. Okay, let's go to the next page. This is going to get us through OWL chapter 4, part 1. This problem here will get us through OWL chapter 4, part 1. And this will get you through the lab next week. So here's what we've got, and this is entitled percent yield. So here's what we've got. It says, what is the percent yield of a reaction that produces 12.5 grams of Freon So that's my actual yield. My actual or experimental. The actual or experimental. It just says you got 12.5 grams. So you're going to do a reaction next week with zinc iodine. You're going to know what you got because it's going to be in your Erlenmeyer flask. So, but it wants to know a percent yield. So what is a percent yield? It's the actual, which is typically your experimental, divided by your theoretical, what you should have gotten. And times 100, and then we just add the percent sign. Okay, so here we've got, we're reacting 32.9 grams. This would be called carbon tetrachloride. 32.9 grams. And experimentally, we got 12.5 grams. Theoretically, how much should you have gotten? So we're going to convert grams to moles, moles to moles, and then moles back to grams. And then the mole ratio step right here, this is just 1-to-1, right? 1-to-1. So let's calculate how many moles this is. One mole carbon 12.01, chlorine 35.45. $153.81 grams. So this is 0.214 moles. So I should produce theoretically 0.214 moles of freon. Well, how many grams is this? We know this is in moles. So 1 mole. $12.01, 19.00, and 35.45. I think we get 120.91. 120.91. Okay, good deal. 120.91. Then 120.91 times 0.214. 25.9 grams we should get. If everything went perfectly, you should get 25.9 grams. But obviously it didn't go perfectly because we only got 12.5 grams. So my percent yield (12.5 grams) divided by 25.9 grams. Multiply that by 100. Add the percent sign. 48.3% yield. So that will now get us through 11 on the quiz. So on the quiz, you can do number 11 now. So you can, chapter 4, part 1 and out. Does anybody know when that's due? It says Tuesday. That should be right then, because we'll have final questions on this Monday. You can do 1 through 11 on the quiz. And we'll see you Monday. Have a good weekend. Oh, where'd my controls go here?